So as we've seen now, we've made a couple little discoveries about our continuity and one-sided limits. That is that we can say that a limit as x approaches c of f of x exists if both one-sided limits exist and give the same value. And we've also looked at continuity in terms of what conditions they meet. And remember, there were three conditions. Number one, that the value of the function is defined at that point. Number two, that the limit as x approaches c of f of x exists at that point. And then finally, that the limit as x approaches c of f of x is equal to the value of the function at that point. We're going to make one further distinction, and that is what we call removable versus non-removable discontinuities. And here's the difference. We say that the limit as x approaches c of f of x, if that exists, it is a removable discontinuity. And if it does not exist, we say it's a non-removable discontinuity. All right, so let's go ahead and talk about those ones right here. Here's our first function, f of x. In this function, we have f of x is equal to 1 half x plus 1 when x is less than or equal to 2, and f of x is equal to 3 minus x when x is greater than 2. So we're going to have to discuss removable or non-removable discontinuity at x equals 2. So that's one thing we definitely want to look at. Do we have continuity, and is it a removable or non-removable discontinuity at that point? Well, I can say for sure f of 2 is defined right here. F of 2 is equal to 1 half times 2 plus 1, which is to say 1 plus 1, which is 2. On the other hand, if we take the limit as x approaches 2 of f of x, we'll note that we have to evaluate this from the left and the right and see what happens. So let's take a look at our left-hand limit. The limit as x approaches 2 from the left of f of x is going to be this piece right up here at top, right? 1 half x plus 1. And if we evaluate this limit, looks like we can evaluate it by substitution. And sure enough, from the left, we would say that this function was equal to 2. On the other hand, let's take a look at our limit as x approaches 2, this time from the right. And when we approach 2 from the right, you note that we're using the bottom part of this function, 3 minus x. And as we evaluate this, as we let x equal 2, we know we get 1. So at this point, our limit does not exist. And even though the function is defined at that point where the limit does not exist, we're going to call this a non-removable discontinuity. Discontinuity. All right. And how about this one? Well, our value that we have to look at in this case is also 2. Right? And it looks sort of weird the way that we have it defined right here, but what are we saying? Well, in this particular case, we can assure ourselves that f of 2 is defined, and we give the value as 3. Specifically and only at that point, y is equal to 3 when x is equal to 2, but that is the definition we've given it. All right, what else could we say? Well, we would certainly have to look at our limit as x approaches 2 of that function f of x, which means that we're going to have to divide this up into left and right limits. So if we take our limit as x approaches 2 from the left, as x approaches 2 from the left, this part right up here, we have 1 half x plus 1, and by substitution, we're going to get 2. Looks kind of familiar, doesn't it? On the other hand, let's take our limit as x approaches 2 from the right. So we're taking this time the limit as x approaches 2 from the right. Oh, we've changed a little bit here. This is tricky. 4 minus x this time. All right, what happens as x approaches 2? Well, 4 minus 2 by substitution gives us 2. And so our limit does exist and its value is equal to 2. Now, the problem is that it's still a discontinuity because it doesn't meet the third condition, because the limit as x approaches 2 of f of x is not equal to f of 2 itself. Therefore, we're going to say, well, because the limit exists, this is what we call a removable discontinuity. So we might ask the question, well, why are we calling it removable? Well, we say the word removable in essence because if we were to redefine this one single value at x equals 2, we could remove the discontinuity. If instead of f of 2 being equal to 3, we just rewrote this one piece and said f of 2 was equal to 2, well, suddenly we have a function that is continuous, even though the limit from the left and the right approaches it at different behaviors. It doesn't matter. As long as it meets the conditions that f of 2 is defined, the limit as x approaches 2 of f of x exists, and the limit equals the value of the function at that point, it would be continuous. But for that one point, it's not continuous. We call it removable.